Okay, so here we have question number 11 from February, March 2018, question paper 4. And in this question, it's a sequence question again, another request for a sequence question. We have to complete the table. So we've got to basically find the sixth term of each of these sequences first, okay? And then part B, we've got to complete the nth term for sequence A, B, and C, A and B, and then switch for the nth term of A, B, and C, and then, okay. So let's just start with A, completing the table. So we see here for the first expression, you've got 0, 1, 4, 9, 16. As you can see, these are the square numbers. These are the square numbers. 1 squared, 2 squared, 3 squared, 4 squared, that's 0 squared, so that's going to be 5 squared. 5 squared is 25. And then you got 4, 5, 6, 7, 8, 9. You're thinking, are you serious? Is this a real question here? And then you got this sequence which seems really strange. -4, -4, -2, 2, 8. Now we can tackle this in many ways, okay? One of the ways we could tackle it is to say, okay, it's not changing. It's going up by 2. It's going up by 2. By 4, sorry. It's going up by 4. From -2 to 2, it's going up by 4. Then it's going up by 6. So we can see there's a pattern here. It's going to be going up by 8. So you're going to get 16 there, okay? Now another way of doing it, actually, which is a very clever way, is if you look at a sequence and you're not very sure about it, you can always check to see how it relates with other terms in the sequence. So if you see here, you've got A and B, and you've got 0, 4, -4, 1, 5, -4, 4, 6, -2, 9, 7, 2, 16, 8, 8. You can see if you do A minus B, if you do sequence A minus sequence B, you get sequence C. 0 -4 is -4, 1 -5 is -4, 4 -6 is -2, 9 -7 is 2, 16 -8 is 8, and 25 -9 is 16. Okay, so there's also that way you could do this, you can solve this problem. Okay, sometimes there's no other way except that. Okay, the sequence is so strange that you won't be able to work out a pattern the way we did. In this case, you could do either. Okay, so then it says find an expression for the nth term of sequence A. All right, sequence A, you can see 0 is the first term. The first term is 0 squared. The second term is 1 squared. The third term is 2 squared. The fourth term is 3 squared. The fifth term is 4 squared. If I say like the 10th term, it's going to be 9 squared. It's always, so the sixth term is going to be, you take 1 away and square it. So it's going to be 6 minus 1, which is 5 squared. So the nth term is going to be, take 1 away from n and square it, n minus 1 squared. Okay, so that's n minus 1 all squared. Okay, that's an easy way to do a quadratic sequence when you recognize the square numbers in the sequence itself. Sequence B, well, that's a pretty simple one. It's going up by 1. 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So it's got something to do with the 1 times table, because it's going up by 1. So it's got something to do with 1 times n. 1 times n. It's going up by 1, so it's 1 times n. 1 times table goes up in ones. But if I leave it like that, the first term will be 1. I want the first term to be 4. So I want it to start from 4. Okay, so to make it start from 4, I have to add another 3 to it. So if I have the sequence n plus 3, so, okay, the first term will be 4. The second term will be 2 plus 3, 5. Third term will be 3 plus 3, 6, and so on. Okay, so it's going up in ones, so it's got something to do with 1n. Okay, if it was going up in 4s, it'll be something to do with 4n. Okay, a lot of people make the mistake. It's going up in 1s, it's got something to do with n plus 1. No. It's going up in 4s, it's got something to do with n plus 4. No. It's going up in 4s, it's got something to do with 4 times n. It's going up in 1s, it's got something to do with 1 times n. And then you add or subtract what you need to make it start from the right place. Okay, part C. Find the value of n for which the nth term of sequence A is 576. So you got n minus 1 squared, and we want it to equal 576. Let me sort out my handwriting there. It's a bit messy there. Okay, that's 576. 576. So basically what we've got to do is we've got to expand this bracket. So you'll have n. No, we don't actually. We don't. There's a very easy way of doing this. You could expand the bracket, bring 576 to the side, factorize it again, find the value, two values of n, and so on. Or you could do something very simple. You could just say, let me find the square root of both sides. You have n minus 1 is equal to the square root of plus or minus the square root of 576. But as we know that the nth term must be a positive number because the first term is 1 and you don't have a negative any term. You know the first term, you've got the second, the third, the fourth, the fifth. It starts from the first term, it goes forwards. You're not going to worry about the negative square root of 576. We only care about the positive one. So we can just write that. That means a positive square root. Okay, so we're going to take the calculator. And we're going to find the square root of 576. 576. So the square root of 576. That gives us 24. So we got n minus 1 equals 24. So n is equal to 25. So the 25th term of sequence A is 576. And, you know, you can see that it's going to be 24 squared, which is 576. Okay. Now, find an expression for the nth term of sequence C. Okay, so now they're asking for the nth term of the sequence. Okay, so we know it's going to be, this was what? This was n plus 3. So basically, there's two ways we could go about this. We could go about this the quick way. We could say, okay, it's basically it's sequence A minus sequence C. We've worked out that pattern. So sequence A minus sequence B gives you sequence C. So sequence A was n minus 1 squared. And sequence B was n plus 3. So take away, make sure you put this in a bracket because that will affect everything. So that's going to be n minus 1 squared is n squared minus 2n plus 1 minus n minus 3, which is n squared minus 3n minus 2. Okay, so n squared minus 3n minus 2. Let's see if that works. We said n squared minus 3n minus 2. Does that work? Let's see. Let's try, for example, randomly choose, say, the fourth term. Okay, let's put 4 into there. You have 16 minus 3 times 4, which is 12, minus 2, 16 minus 14, which is equal to 2. 16 minus 14 is 2. It works. Okay, seems to give us the right answer. Okay, for a randomly picked term of the sequence. So n squared minus 3 and minus 2, so that shows that we manipulated the equation correctly. Okay, now I'm also going to show you a different way of doing this question once I finish part D. In case you didn't notice that pattern and you worked this pattern out, or you worked out the next term of the sequence by just continuing it on like this, I'm going to show you how to work out that sequence with that if you did not realize that it's just sequence A minus sequence B. Okay, so just bear with me. Let me finish part D, part 2 first, so that everyone if somebody doesn't want to listen to it, they can just switch off. So part C, it says find the value of the 30th term of sequence C. Okay, so that's pretty simple. You're going to put n equals 30. So you have 30 squared minus 3 times 30 minus 2, that's 900, minus 90, minus 2, 900 minus 92, okay, which is going to be 808, I think. Let's see how good my mental maths was there. So we're going to have 30 squared, minus 3 times 30, minus 2. Voila, 808. Yes, okay, not too bad. All right, so now I'm going to now show you how to find the nth term of this sequence. Okay, if you didn't know how to work that out. So what I'm going to do is, now I'm going to pause the video. I'm going to bring these numbers down, and then I'm going to show you. Okay. Okay, so as I was saying, we're going to find the nth term of this sequence. Minus 4, minus 4, minus 2, 2, 8, 16. Now we saw that the pattern was that every term to term, you can see that there's a pattern arising that it goes up by 2, then by 4, then by 6, then by 8. okay, which we could therefore say that there's a pattern in the second row that's going up by 2, by 2, by 2, by 2. Now, if there's a constant number in the second row, I know it's got something to do with n squared. It's got to be a quadratic sequence. It'll have some relation to n squared. And the number that appears in the second row are half of that. So it's 2 over 2n squared, which is 1n squared. If that number was like 4, or if it was 4 plus 4 plus 4 plus 4, I would say 2n squared. If it was 6 plus 6 plus 6, I would say 3n squared. If it was like 3 plus 3 plus 3, I'll say 1.5n squared, so on. So whatever number appears here, it's that number divided by 2 times n squared. That will be the pattern of the sequence. So we have some relation to that. So I'm going to write down n. I'm going to write down n squared. So n is first term, second term, third term, fourth term, fifth term, and sixth term, right? 1, 2, 3, 4, 5, 6 I've written there. Now I'm going to write down what n squared is, which is n1 squared, which is 1, 2, n2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, and 6 squared 36. Then I'm going to leave a gap. I'm going to leave a gap in my sequence, and I'm going to write down the actual numbers that appear in the sequence, which are minus 4, minus 4, minus 2, 2, 8, and 16. Okay? And then I'm going to say to myself, how do I get from 1 to minus 4? Well, I've got to take away 5. How do I get from 4 to minus 4? Well, I've got to take away 8. From 9 to minus 2, well, I've got to take away 11, don't I? 9 minus 11 is minus 2. 16 to 2, I've got to take away 14. 25 to 8, take away 17. 36 to 16, I've got to take away 20. Now, in this particular row here, there's a sequence that's appearing. It's a linear sequence, isn't it? Okay, this sequence it's going down by 3. All right, what goes down? How can you show when something goes down by 3? What do you have to do? It's something to do with the negative 3 times table. So it's got something to do with minus 3n. It's going down by 3. This expression will make things go down by 3. However, we want it to start from minus 5. This will start from minus 3. I've got to start from minus 5, which is 2 lower than minus 3, so I've got to take away 2. So you see, just as 1 minus 5 is minus 4, 4 minus 8 is minus 4, 9 minus 7 is minus 2. So this sequence must be n squared minus 3n minus 2. And there we have it. That's a sequence, exactly the same sequence we got, okay, by just subtracting the nth terms of the two sequences before it. That was far easier, okay, but if you weren't able to spot the pattern, it's still not impossible to do this question. Okay, it's still possible to do it using quadratic sequences, and maybe there'll be a couple of questions later on that I do, where I show you how to deal with those when the n squared term is not 1, when not 2. It might be, for example, 3 come up, or a 4 come up, or a 5, even if a 1 comes up here, how to deal with it. Okay, so that's basically question number 11 from this paper done. I think I've got it all right. We'll find out for sure when the mark scheme comes, but I'm pretty sure that this particular question is fine. Thank you for watching.